In today's note, we are going to review solving equations. So I'm just going to go over a few examples of all the different types of solving equations, and then you can pause and try these on your own, and then check in to see if your answers are correct. Or you can continue to watch and see how to walk through each of these steps. So to start off, we'll start with A, which is 8 plus m equals -2. This is a one-step equation. There's multiple ways. There's two ways you can think of doing it. You can think of canceling things out. So in this case, I want to cancel out the 8 on the one side to get m by itself. So in order to do that, I do the opposite operation, or -8. -8 from both sides to keep things balanced. And I'm left with m equals -10, which is my final answer. Again, the other way you could do it, if you have 8 plus m equals -2, you know you're going to have to move the 8 over to the other side, where it becomes the opposite operation. So either way you choose to do it is fine. Again, I'd say the biggest thing is to work on simplifying down rather than horizontally. So the next one, B, we have 2y minus 7 equals 13. So again, this is a two-step equation because there's two things to do. I'm just going to do it the simplified way. I'm not going to, or actually no, I'll go through and show the steps that way. If you are confused on what we're doing, you can see kind of the process. I want to get y by itself, so I'm going to cancel out the -7 first, right? Remember, use reverse BEDMAS to figure out where to start. So in this case, I have to add 7 to both sides to cancel out the -7. 2y equals 20. So those cancel out. I'm going to divide both sides by 2 to cancel out the multiply by 2, and y equals 10. C, -3s minus 6 equals 9. Again, same idea as the last one, same types of steps. Two-step equation, so I'm going to get rid of the subtraction first. So the -6. So I'm going to add 6 to both sides. Cancels out on one side. -3s equals 15. Divide both sides by -3, which is the number combined with the s. S equals -5. D, we have 3x plus 7 equals 2x minus 3. So this is a multi-step equation because I have variables on both sides of the equal sign, and I want to get them onto one side. I'm going to cancel everything out to move my variables onto the left side. So in order to get rid of this 2x, I need to subtract 2x. I can only subtract 2x on the other side from the 3x. But again, I do have to do it to both sides. So the one side, the entire term cancels out. We're left with 1x plus 7 equals -3. Again, look in front of the term for the sign. So in this case, that negative or that minus is still there in front of that 3. So it's still a -3. Now we're down to a two-step equation. I want to get x by itself, so I'm going to -7 from both sides to cancel out the +7. And I get 1x equals -10, or basically just x equals -10, which is my final answer. Moving on to E, 4 minus 3p minus 2 equals p minus 10. So this is a multi-step equation with brackets. I want to drop the brackets first So what I have to do, this negative, or we can see it as a -1, has to get multiplied to everything inside the bracket. So I'm left with 4 minus 3p, because -1 times 3p, and then -1 times -2 is +2, equals p minus 10. I can simplify some like terms on the left side, the two constants or the two numbers. So -3p plus 6 equals p minus 10. And now I'm down to the multi-step equation. I want to get my p's all on one side, so I'm going to subtract 1p from the one side, subtract it from the other. Remember, it's combining like terms, it's not canceling out here on the one side. So -3p minus 1p is -4p plus 6 equals -10. I want to get rid of the plus 6, so I'm going to minus 6 from both sides. -4p equals -16. And lastly, I'm going to divide by -4 on both sides. P equals 4 is my final answer. So moving on from E, go to F. F is 3 times, in brackets, 2k minus 5 minus k equals 4 minus 3k plus 7. Here I have a couple set of brackets, so I'm going to multiply these terms through. In the second set, it's just that invisible -1 that I'm going to multiply through. So in the first set, I have 6k minus 15 minus k still remains, and then I have equals 4 minus 3k minus 7. There's a couple of like terms on either side that I can combine. So I'm going to simplify that first. So 6k minus k, or minus 1k, is 5k minus 15, still remains. 4 minus 7, I have -3, and then the minus 3k still remains. Now I want to collect my like terms, or sorry, I want to get my variables all on one side. So I'm going to move the minus 3k over, which means plus 3k on both sides. One side cancels out. 8k minus 15 equals -3. I'm going to add 15 because I want to deal with this subtraction first. I'm going to add 15 to both sides. One side will cancel out. 8k equals 12. And finally, I'm going to divide both sides by 8. One side cancels out. K equals 3/2. Right? Or 8/12, but I just simplified it or reduced it to 3/2. So that was a very complex equation with brackets. As we move on to G, now we're going to introduce some of our fractions. So b minus 4 divided by 3 equals -5. To cancel out the fraction, I'm going to multiply both sides by 3, or in this case the denominator. The one side will cancel out with the fraction, so b minus 4 equals -15. And now I'm down to a one-step equation. I'm going to add 4 to both sides. One side cancels out. B equals -11. Oops, I guess 7. And our final answer, or final question, H. So we have y minus 8 divided by 3 equals y plus 4 divided by 2. So there's two ways you could do this. One, you could multiply each side, say multiply it by 3, and cancel out the 1. So you get y minus 8 equals 3 times y plus 4, that entire top, all divided by 2. Then multiply both sides by 2 to cancel out the 1 fraction on the other side. And you're left with 2 times y minus 8 equals 3 times y plus 4. Another option, you could also say if you had y minus 8 divided by 3 equals y plus 4 divided by 2, you can multiply by a common multiple of both 3 and 2, which in this case is 6. So if you multiply everything by 6, on one side the 6 and the 3 will cancel out and leave you with multiply by 2 times the whole thing equals the 6 and the 2 will cancel out and leave you with 3 times the whole thing. So again, we still get to the same answer. Or again, a third option, because we only have one fraction on one side and one on the other, we can do something else. We can, in this case, cross multiply so that the 2 comes up to the left, the 3 goes up to the right. So 2 times y minus 8 equals 3y plus 4. So those are basically 3 options of how you can get to the same step of getting rid of the fractions. The first 2 will be applicable, or these methods can be applied to any type of fraction problem. The third method, where we cross multiplied, will only apply if it looks similar to this question, which is you only have one fraction on one side and you have one fraction on the other. So that's something to be careful of. So it may not work on all situations depending on what it is. Either way, we're just going to all simplify to the same spot. So I'm going to continue. So we have 2y minus 8 equals 3y plus 4. Let me just add in some shapes just so we can indicate what we've actually done. So all 3 methods basically lead you to the same answer. Here I have brackets now, so I want to get rid of the brackets. I'm going to multiply the outside term, or the multiplier, through to the brackets. So 2y minus 16 equals 3y plus 12. I want to get my variables on one side, so I'm going to minus 3y on the one side, minus it on the other. One side cancels out. I'm left with minus 1y minus 16 equals 12. I'm going to add 16 to both sides to cancel that out. That cancels out. I get negative 1y equals 28. And then finally, I need to get y by itself, so I don't need that negative 1 in front. So I need to divide both sides by negative 1, and y equals negative 28 is our final solution for the entire thing. So there are multiple ways to at least get rid of the fractions, but then the rest of the steps should all look fairly similar. And again, this is just a review of solving equations, looking at all the different types and how to solve them.